Hey guys, so I'm putting up this video just as a little study help for Ionic nomenclature since some of y'all are still having a little bit of trouble with it. So, first off, let's just review that Ionic means that it has a metal, right? So anything that has a metal in it is going to be an ionic compound. So for example, it could be aluminum, it could be magnesium, it could be iron, any of these metals, lithium, so on and so forth. If any of these are in the compound, then it is definitely an ionic compound. And whenever we want to name or write the formula for an ionic compound, what you're usually going to concern yourself with is the charge on the atoms. So ionic compounds are charged compounds. They're usually a positive and a negative charge combining together. So for example, I can have something like lithium bromide. So lithium bromide here. Lithium, if we look at a periodic table, has a positive 1 charge. Bromide is just bromine, we're just changing the ending from "ine" to "ide", and that has a charge of -1. So when I write the formula, it's just going to be Li and Br. Easy way to remember this is to do just the crisscross method. So I write the charges up top, right, and I'm just going to put those down at the bottom next to the element across. So for example, if I did this with calcium instead, calcium has a positive 2, bromine has a -1, so 1 and 2, so I get CaBr2. Again, I can do aluminum and bromine. Aluminum has positive 3, bromine has -1. So you just cross them, and I get AlBr3. Now I can also have elements where it's 2 and 3 for the charges, right? So I could have something, for example, like aluminum oxide. So I have aluminum and I have oxygen. Again, aluminum is +3. Oxygen, if you look at the periodic table, is -2. So when I crisscross these, I get Al2O3. So that's pretty much the common thing you're going to see a lot, is you'll either have something that's 2 and 3, or it could be reversed, 3 and 2, or you'll have elements that are 1 and elements that are 2 or 3, or elements that are just 1 to 1. So those are the easiest versions of this, where it's just 2 elements. But ionic compounds can also come with polyatomic ions. So for example, nitrate. Now this is something that you don't have to memorize, it'll be on the list for you, or we'll give it to you. But nitrate is an ion with a -1 charge. So if I were to combine it with something like, let's say, calcium, that has a positive 2 charge, I'm still just going to do my crisscross method. But the thing is, this whole thing here is what has my -1 charge. The entire NO3. That is what has my -1 charge, so when I crisscross, the 2 goes to the outside of that parentheses. So I get calcium, parentheses, NO3, and then 2. And I can do this with others. So I can have, for example, lithium and sulfate is another one. If you need it, it'll be on your list. It has a -2 charge. So in this case, lithium has +1, and when I crisscross, I will just get Li2SO4. I don't really need these parentheses here. I could get rid of them since I only have the 1 sulfate, but it doesn't really do any harm to have them there. So that's up to you, really. And again, I can have these that are slightly more complicated. For example, I could have something like calcium, again, +2, and phosphate, which is -3. Whole thing, remember, -3. So now this +2 goes to this side, outside the parentheses. This 3 goes here. So now I would get Ca3, parentheses, PO4, 2. So pretty simple and straightforward. As long as you know how to do the charges and crisscross, then it should work out just fine. Where things get a little bit stickier is when we have something that is a transition metal. So transition metals are the metals in the middle. So anytime I have anything that is not in the first two columns, or in the column labeled +3 on your periodic table, those are going to be my transition metals, the metals in the middle. And except for my 3 exceptions, which my exceptions are zinc, cadmium, and silver. Zinc is +2, cadmium is +2, that should really be a capital, and silver is +1. So except for these 3 exceptions, all those transition metals in the middle can have different types of charges depending on what they're bonded with. So for example, I can have FeO here, or I could have FeO2. Both of these are iron oxides. What's different is the charge on the iron. So in this case, I can have a -2 charge on my oxygen like normal, right? But the charge I have on my iron is going to depend on how many oxygens I have. And we can kind of just do crisscross in reverse for any of this. Anytime I have one of these transition metals, I just look at what my subscript here is, right? And I'm just going to trace that back up. So for example, if I have -2, I know oxygen has, there's only one of them, but I know it has a -2 charge. So my iron on this side has to be +2 for them to cancel out. They always have to cancel out. On this side, so I have oxygen here, -2, but I have 2 of them. So the total is going to be -4, right? So it's -2 times 2. So I get -4. So that means my iron over here, since I only have the one of them, would have to be +4 to balance out. So transition metals are always going to depend on what they're bonded to. Now, when it comes to the naming, everything besides the transition metals is pretty easy. It's always just going to be the name of the metal and the name of the other element ending in "ide," or a polyatomic. So for these guys up here, since it's just 2 elements, I have lithium, I have bromide. That's bromine, right? So bromine. And all I'm doing is this ending I'm taking off, and I'm replacing it with ID. Same thing down here. I have calcium, bromide. So it's just always the metal, and then the second word ending in "ide." For my polyatomics, so these guys here, again, the metal's always just going to be the metal, right? So it's still just calcium. And then the second part's always just going to be the name of my polyatomic. So whatever I have here in the parentheses, I just go on my list in the back of my periodic table and I look for what the name of this guy is. So if I see this formula, I see calcium, good. I go look for what's NO3. NO3 is just nitrate. Same thing here, I have lithium. And then this guy here is sulfate. Actually, little mistake. SO3 is sulfate. Whoopsies. That's my bad. But you just go look on your list and find whatever matches is in the parentheses, and you're good to go. Going backwards on these, relatively easy. If it ends in "ide," you know it's just going to be an element. So bromide, chloride, fluoride, you just go find the element that sounds like that. So bromide sounds like bromine, chloride sounds like chlorine, fluoride would sound like fluorine, and that's the element you're using. And then if we're going backwards here, anything that ends in "ate" or "ite," some of them will end in "ite," I-T-E, right? So if it ends in one of these two endings, "ate" or "ite," that's going to be one of your polyatomics that you go find on your list. And then the trickier ones is our transition metals. So these guys, since the charge can be different, we have to use something to tell which one it is. So what we do is we put the name of the metal, iron, and then we put Roman numerals in parentheses, and then we put the name of the other element, so like oxide. So this is an iron oxide, and this guy's going to be an iron oxide. Tell the difference, I put a Roman numeral that represents the charge. So over here, I found out my charge on my iron has to be positive 2, so this is iron 2. This guy is positive 4, so it's iron 4. Pretty simple and straightforward. You just got to keep in mind that this tells me the charge on one atom of the metal. Other than that, it's pretty straightforward. If I want to go backwards from the names, I always just, keep in mind charges, right? So calcium and nitrate. I know calcium's positive 2, right? I know nitrate's negative 1, so I do the crisscross. And then same thing up here. Just find the charges. Lithium is positive 1, bromine negative 1, do the crisscross, and I would get to my formula. The only other thing you got to be careful of is when we do have transition metals that have more than one. So for example, I could have, let's see, we could have something like Fe2O3. So now I have more than one iron atom, right? So again, I know I have negative 2 on my oxygen. I'm multiplying it by this 3. So times that 3, I get negative 6. And I know negative 6 has to be balanced out by a positive 6 on this side. And I've got a 2 here. So 2 iron atoms make up positive 6, so I just divide by the 2, and I get 3. So each one of these irons is positive 3. I've got 2 of them, so I've got 2 iron 3s. So if I went to go name this guy, it would be iron 3 oxide. Wouldn't name it iron 6, and I wouldn't name it iron 2. It's iron 3 because each of my metal atoms has a positive 3. Alright, hopefully this helps you guys out a little bit. As always, if you have any questions, you can always come ask me.